Hi everyone, this is Janine aka Janine The Tutor. As you know, now is a very difficult time for all students. Many students and families are deeply affected by the recent school closure. And as a part of OneClass, we are very fortunate that we are able to adapt to this circumstance really quickly, and that's why we want to help students stay on top of their studies by running free and daily classes for math and chemistry from grades 11 to first year college and university. So for today's class, I will be going over the most popular Q&A questions that we've received from our end on OneClass homework help. Oh, and also, actually, before I forget, if you know anyone, your neighbors, your friends who might benefit from this class, just call or text them and ask them to join right now. So, okay, cool. So before anything else, you know what to do. Just give me a yes if you can actually hear me coming through and you can see my screen. So you're supposed to see two, I guess, windows. So the first one would be the question. So this is from homework help, and here will be my worked out solutions. Okay, great. So the first question that I received is what is the next value? So you have 2, 3, then you have the letter E, then you have 4, 5, then you have the letter I, then you have 6 and 8. So interestingly, if you think about your alphabets, right, you can actually add the 2, right? So they're saying that if you have 2 plus 3, you get 5, right? So since the letter E is the fifth in the alphabet, right? If you just want to visualize that, if you have A, B, C, D, and E, so this is like the fifth one, right? Starting from A. So if you know that this is the fifth one, right? So you kind of see a pattern over here, such that if you added 2 plus 3, that's going to be 5, right? So this is E. And if you have 4 plus 9, right, you're going to expect that if you're going to take the sum of two consecutive numbers, in this case 2 and 3, then you have 4 and 5, you know that I is supposed to be 9, right? It's supposed to be the ninth letter of the alphabet. So that's your assumption. So maybe we can take a look at that. So you have E, then you have F, G, H, I, right? So 5, 6, 7, 8, 9, right? So this is the ninth letter of the alphabet. So therefore, if you have this, okay, so going back to what I was saying, you're expecting that if you're adding 6 and 8, right, what's the next letter? Or is it even a number or a letter, right? So as you can see, there is a trend or there is a pattern. If you added 2 and 3, you get a sum of 5, right? And that would correspond to E, which is the fifth letter of your alphabet. And then if you have 4 plus 5, right, so that means that's 9, right? You would take your alphabet, right, and you're going to find which is the ninth letter. And in that case, that would be I, as you can see over here. So now, if you're taking 6 plus 8, that equals to 14, right? So if you're adding the 2, right, so you're going to look for the 14th letter of the alphabet. So you have F, G, H, I, J, then you have K, L, because we know that this is the 10th, so this is the 11th, 12th, 13, 14. So you actually stop at the 14th letter. So K, L, M, N. So you're going to expect that the next one that follows 6 and 8, specifically that follows 8, right? After that, you're expecting that your answer would be N, because 6 plus 8 is 14, and the 14th letter of the alphabet is N, right? So let's see what they wrote. On adding the first two numbers, we get 2 plus 3, which is equal to 5. And that's true, right? The given pattern is the combination of numbers and alphabets. And in the third place, there is an alphabet E. That's right, as we know that E is the fifth letter in the alphabet order. Similarly, when we add the numbers 4 and 5, we get 9. And the alphabet comes after the numbers 4 and 5 are I. The letter I comes at ninth place in the alphabet order. Similarly, on adding 6 and 8, we get 14. The letter on the 14 places in the alphabet is N without an N, without an S here. Hence, N comes next. That's right. So, yeah, this is perfect. Although I would have to make it I would say I would prefer, if it's quicker, I would just say, I know that there is, like, this is a good explanation, I would say, but maybe if they can kind of shorten it and say, okay, 2 plus 3 is 5, then you can just say the fifth letter of the alphabet is going to be E, and then the next one would be, what was the next one? The next one is 4 plus 5, which is 9. Then you can just go ahead and say, okay, the ninth letter of the alphabet is I. Then you have 6 plus 8, which is 14. Therefore, the 14th letter of the alphabet is N. I think we can just have bullet points. That's just my preference. So, perfect solution and answer. I don't have anything to say. But although I would prefer that if they have a shorter answer. But I think that's very trivial, so solution is correct. Great. Okay, so now let's move on to inequalities. Okay, great. So we have this question. What value of x is in the solution set of 2 times 3x minus 1 greater than or equal to 4x minus 6? Okay, so all you have to do here is make sure you solve for x, right? Okay, so this is the question. We have 2 times 3x minus 1. Then this is greater than or equal to 4x minus 6. Okay, so based from my experience, a lot of students, they just tend to get scared whenever they're seeing an inequality, which I think is mind-boggling because, first of all, you're going to treat an inequality similar to an equation, right? Or an equality symbol. Why? Because you're solving for x, essentially, right? The only difference here is you have a greater than or equal to symbol, right? So there's nothing to be afraid of. I think you just focus on, whenever you get an inequality question, just focus on solving for x the same way as you would expect if you have an an equal, what do you call this? An equation that has an equality symbol. There we go, right? So if you have 2, right, just treat this as solving for x, right? Just isolate x on one side and you get a constant, for instance, in this question. So here you have to distribute 2 to each of the terms, right? So you would get 6x, then you would get minus 2, then this is greater than or equal to 4x minus 6, right? And remember, just treat this greater than or equal to symbol the same way you would see an equal sign, right? So if you have 6x, all you have to do is move 4x to the opposite side. So you would get 6x minus 4x, which is 2x, right? And then you're just going to copy your greater than or equal to symbol. And then because you have a negative 2 here, you need to move that to the right side of your equation. So you would get negative 6 plus 2. So negative 6 plus 2 would be negative 4, right? Then you're going to divide both sides with 2. And as you can see, because this negative sign is not on the coefficient of 2, right? Therefore, there is no need for you to flip the direction of your inequality symbol. That means if it's greater than or equal to, it will remain the same. However, if the scenario changes, right, such that if you have 2x and if 2x is negative as opposed to negative 4, or even if 4 is positive, right? So say, for example, you have negative 2x, right? Whether negative 4 is kept, right, or the negative sign is kept, or if 4 is positive, right, regardless of whatever the sign of 4 is, as long as you have a negative coefficient, so when I say negative coefficient, a negative number, right, multiplied to x over here, that's the only time that you're going to change the direction of your inequality symbol. Otherwise, everything is going to remain the same. You're not going to flip anything, right? So we don't really care about the sign of 4, right? If that's negative or positive, regardless, right? Because you have a negative 2 here, that means you would have to flip the inequality symbol from greater than or equal to less than or equal to. So dividing both sides with negative 2, you get x. So we flip this, less than or equal to, and you're going to have positive 2, right? So even if you kept this negative sign or you just simply had that negative sign over there, it doesn't influence the direction of this inequality symbol. Okay, so that's my whole point with inequality. And I think that's the key point that a lot of students tend to forget. So you have to remember that by now. Okay, great. So because the negative sign is on 4, right? It's not on 2, therefore we just keep this inequality symbol. So if it's greater than or equal to, we're just going to keep that as greater than or equal to. Therefore, we can cancel this and this, we get x, and this is greater than or equal to -2, because a negative number divided by a positive number is still a negative number. Great, so we have x greater than or equal to -2, and let's see what they said. So given this equation, the bracket on the left-hand side is open and we obtain 6x minus 2 greater than or equal to 4x minus 6. That's absolutely right, which is what we have here. And it says now we bring 4x on the left side of the inequality, which is what we did, right? Because initially it was from the right side, so we moved that to the left side. And -2 on the right side of the inequality, which is right, so we get this. 2x greater than or equal to -4, which is what we have here, dividing both sides with 2, right? So we get x greater than or equal to -2, which is what we have just obtained. Then, now, instead of leaving your final answer, which is x greater than or equal to -2, I mean, that's fine, but if your teacher is specifically asking for the interval notation, which they've included over here, you can say that this is -2, right? But in this case, you're going to have a square bracket. The reason being is because you're including -2. So if you have a square bracket, that just means that -2 is included, and then because this is greater than, that means that it's going from -2 to positive infinity. And then close bracket, right? So in that case, this is equal to this. So any is fine. And because they're specifically looking for the solution set, that's why they have your final answer in terms of interval notation. And that's the only reason why. So this is absolutely right. So we can move on to the next question. So just to verify, I don't really have anything to correct, so it's a perfect solution and answer. Okay, so this is an interesting question, and this is going to be a long question, I would say. Okay, so what I can do, I will copy this image and I will paste that into, let's see what I can do. Because we're going to be looking at this, what do you call this? We're going to be looking at this image several times, so I wanted to have a snapshot, and let's include that here. Okay, great. Okay, so here's an image of what I just took from homework help. And just so you know, they're asking which equation is correct regarding the measure of angle MNP, right? As you can see, they're looking for this angle. And what is the right equation? So you have 4 options, right? A to D. So it's going to be a while just because we're going to prove the triangle, right? Which is LQM. And also we're going to be looking at this trapezoid over here, which is Q, M, and P. So if you imagine, okay, so we're now going to annotate on this figure, so just bear with me. Let's use, I'm just trying to think which color is the best one. Maybe we can use orange just so it doesn't camouflage with the purple. Okay, great. Okay, so let's focus on this triangle first, right? So we have the triangle LM, then you have this Q over here. Sorry, let me just connect this just so you can see that it's a triangle. Okay, first of all, Q is at the center. Just so you know, it's at the center of your circle, right? So that's where Q is. And obviously, we're going to have a triangle here. Okay, just imagine that this is your vertex Q, okay? Because I don't think this pen makes it even straight, but there is this triangle over there. You can draw that because you know that this is a point, right? So I know that they don't specifically tell you that there is a triangle, but by intuition, because you know that Q is your center, that means you can connect the dots, right? Starting from your vertex here, from this triangle, this is L, then you have Q and M, right? So just by looking at this triangle LQM, right? So this, and you have this as well, right? But I'm not gonna shade that or turn that into orange just because I think it's just gonna really become so messy. So let's focus on this. So this is what you focus on. So we have triangle LQM, right? So we need to kind of derive the following just by looking at this triangle. So first of all, remember that I said Q was the center and it's a point, right? So if you look at LQ and QM or MQ, you're going to see that they're going to be the radius or the radii of your circle, right? Because Q is your center, therefore, starting from your center, going towards your circumference or your I guess your exterior boundary for your circle, that's going to turn it into a radius, right? Radius means starting from your center, going all the way out, right? So you can actually say that LQ is equal to QM, right? So that's what you can say about your first statement. So LQ is equal to QM, right? And because it's an isosceles triangle, right? If you guys can see this, this is an isosceles triangle because you have two sides being equal to one another. Therefore, this side, right, the opposite angle of that would be angle this, right? So it's angle MLQ, right? So I'm talking about this side, right? The opposite angle would be this, right? And for this side, LQ, the opposite angle is LMQ. Does that make sense? So I'm just drawing this little arc over here to indicate that you have this angle and this angle being equal to one another, and it's because of the fact that you have an isosceles triangle. So for number 2, we're going to say you have Q, M, L, this angle. So QML is equal to QLM, right? Again, there is no preference to where you're starting. You can even start MLQ. It doesn't really matter as long as you make sure that L is the middle one and M is the middle one, right? So this is the one that we're trying to aim for, right? We're saying this M and L, they're equal to one another. Great. So because it's a triangle, right, the sum of the interior angles of a triangle is equal to 180 degrees, right? So that means you're going to say this, right, plus this, and LQM or MQL is going to be equal to 180 degrees, right? So you're kind of sort of proving here, I would say. So you have angle QML, right, which is QML, this angle plus that angle that we said because it's isosceles, right? So they're both equal to one another. We're going to say angle QLM, right? So it's this QLM, and we're going to say that LQM or MQL, as long as the Q is in the middle, so we're going to say this angle plus LQM is equal to 180 degrees because of the fact that the sum of the interior angles in a triangle is 180 degrees. Great. So we know that it's 180, so based from this equation, we're going to say that, okay, we're going to say QML is equal to QLM, right? I mean, the angles, right? Angle QML plus this, right? So we're going to combine them into just one term. And we're going to say that's twice of that. Why? Because we're saying angle QML is equal to angle QLM. So we're going to say twice of angle QML plus LQM, right, is equal to 180 degrees. So I'm just going to say that this angle and this angle, they're equal to one another. And because we're looking at two of them, so that's twice of angle QML. Okay, great. So we have that QML over here. And if you look at this LQM over here, can you guys see that? LQM. So this is basically what you call your central angle, right? This over here, I don't want to mark it because it's going to get so confusing, but basically this angle Q over here, you can say that because it's a central angle, essentially this angle Q would be equal to Z, right? Or Z. The reason being it's because it's a central angle. So if you recall the relationship of your arc and also your angles within your circle, right? If it's a central angle, so whatever this angle Q is, that's going to be equal to this Z or Z, right? Because it opens from here to here. So this Z is exactly equal to LQM or just this, right? So we're going to say that this is plus Z and this is equal to 180 degrees. And the reason why we're equating this and turning this into Z is because, as you can see, all of your answers, your options are basically expressed in X and Y and Z, right? So that's why it's important to kind of change your variables starting from this point. Okay, so we have that for Z. Now maybe we can look at, let's see, this line. Can you guys see this? So L, M, and we have N over here. So L, M, N is in fact a line, right? A line segment here. L, M, N. Okay, so maybe we can actually draw some information from that. Okay, so this is going to be in this color green. I'm not sure if you guys can see this. Hopefully you guys can see that color. It's not too bad. Okay, so we're going to be focusing on line LN or LMN to be specific. Okay, let's keep this as LN. So it's from this point to this point, right? Okay, let's keep it as a line segment. Okay, so we have line segment LN, right? Because you have a vertex here, so you can't really say that this is a line and you have this point, so let's just keep this as line LN. So you can actually say that this is also a straight angle, right? LN over here is a straight, actually LMN is a straight angle. So okay, maybe we can take a closer look. So if you see this, basically if you draw a vertical line from L to N, right? And then can you guys see this MQ? So there is a point at M, right? That's where this line and the circle kind of intersect. So if you have a line, right, from M to Q, and maybe I can do that right now because okay, can you guys see that? So that creates two angles, right? You have an angle here and you also have an angle here, right? And basically they are a linear pair, right? So what's a linear pair? Basically it's two angles, right? They're adjacent and they're supplementary. That's what a linear pair is. So the linear pair are respectively LMQ, right? LMQ, or you can say QML, and then the other angle pair would be QMN or NMQ, right? It's up to you. It doesn't really matter which one you're naming, but maybe we can start naming from the Q because we've been doing that all this time. So from this information, we can say that first we have QML, this angle over here, forms a linear pair with QMN, right? So angle QML and angle QMN is equal to 180 degrees because they're adjacent and they're supplementary. So because they are a linear pair, right? So maybe we can start isolating for angle QMN, and I'm going to get into that in terms of why we're isolating for QMN. And just so you know, the reason why I'm breaking this down for you is because if you look at this, if we don't go through them step by step with the figure, I think it's just going to be very confusing because this is geometry after all. So I need to go through this with you step by step so it's easier for you to visualize, and we're going to check this after. So, okay, great. So as I was saying, you have to isolate for angle QMN, right? And why are you isolating for QMN? Well, remember for QML, we had this equation, right? So we're taking QMN, we're taking 180 degrees, and we're subtracting that from angle QML, right? So I'm just moving this QML because it's a measurement. We're going to subtract because we're moving this to the opposite side of the equation, and as a result, you get a negative sign because it's now positive. So QML, just going back to this, right? If you go back to this equation, when you isolate QML, you're going to see that QML is equal to 180 degrees minus Z, and this is over 2, right? Which we can then simplify, right? Saying this is 90 degrees minus Z over 2. Can you guys see that? So what we're going to do is we're going to say, okay, so QMN is equal to 180 minus this, right? Because we're saying angle QML is equal to 90 minus Z over 2. So make sure you have that bracket because you're going to distribute the negative sign. Okay, great. So once we have that, we're going to say we have 180. This is minus 90 degrees. This is plus Z over 2, right? Because this negative sign gets distributed to this negative Z over 2. It becomes positive Z over 2. Then you have 180 degrees minus 90 degrees. So this is 90 degrees plus Z over 2. So once we know what angle QMN is, right, we can go ahead to the next figure. Actually, it's the same figure, but to the next polygon, which is the trapezoid. So we have this trapezoid. So again, I'm going to see if I can copy this. Because we're going to be drawing a trapezoid, and I think it's just easier for you to have the image right in front of you, and it doesn't work. Great. Okay, give me 1 second, guys. Okay, so what I can do, maybe I can copy this. Okay, so I guess we just have to deal with this. Or maybe I can drag this. Give me 1 second. Let me try this. Okay, great. So I was able to drag this. Okay, so we can move on to the trapezoid now. Okay, so remember what I said about the trapezoid because you have this Q over here. So we're still looking at the same figure, but now we're taking information based from the trapezoid. Okay, so maybe we can use a different color. So let's use red. Have we used red? No, we haven't used red. So let's use red for the trapezoid. So because we said that Q is a point, so we can draw a trapezoid over here, and yeah, this is supposed to be a straight one. Great, so we have that trapezoid. Can you guys see this? M, Q, P, N, right? Or Q, M, and P, doesn't really matter. Just make sure that when you read your trapezoid, right, it's from one vertex to the other without skipping any of the vertices. Great, so we have this trapezoid, and just remember that this is a right angle because we know that this is a radius and it's exactly a right angle. Yeah, because it's straight. Yeah, this is supposed to be straight. Okay, maybe I can make this better. Okay, great. So yeah, we've said that this angle over here, this is a right angle. So let's go back to what we were referring to. So remember in a quadrilateral, or in a trapezoid, because a trapezoid is in fact a quadrilateral, so the sum of the interior angles in a quadrilateral, right, is 360 degrees, and therefore it's the same for a trapezoid. So in that case, if you added all of your angles, so now we're looking at a trapezoid, so we're focusing on angle Q, angle M, angle N, and P. We're going to say that in this trapezoid, Q, M, P, N, so this is the polygon that we're focusing on. So we're looking at angle Q, angle M, angle N, and angle P. Maybe let's go by order, Q, M, P, N, since that's what we started with. Q, M, P, angle N. There we go. So yeah, this is going to be 360 degrees, right? So it's equal to 360 degrees because of the fact that a trapezoid is a quadrilateral, and what do we know about quadrilaterals? The sum of the interior angles is supposed to be 360 degrees, right? So now, right, we see that this Q, because it's a central angle, right? So the relationship between a central angle and its arc is going to be equal to one another. So you can say that angle Q is also equal to Y, right? Right here, because Y is from this point to this point, so it's this arc. So we can say this is Y. For angle M, right? So what about angle M? Well, it's this point over here, right? So that means this is also going to be 90 degrees, right? It's because if you have this line again, you're going to see that this angle M creates a 90-degree angle. If you have another line that's kind of connecting from this point to this point, you're going to see that angle M is 90 degrees. So that's why this is 90 degrees, and you have angle P. So for P, so angle P is, let's see, so right here. For angle P, this is in fact Z over 2 plus 90. And how do I know that? Because if you look at QMN, actually, hold on. Angle P is 90 degrees, right? That's what we said. And then we had QMN, right? So QMN is essentially equal to angle M, right? So this angle M would correspond to QMN, which is here, right? So this is angle M. So this is equal to angle M. So we're going to say angle M is Z over 2 plus 90 degrees, right? So that's for angle M. And then for angle P, this is the one that's 90. So it's not angle M. Angle M is 90 plus Z over 2 because we said QMN from this statement coming from this line segment LN. We're saying that angle QMN is equal to angle M. So that's right here. And then for P, because I've already indicated that it's 90 degrees, right? It's a perpendicular bisector. So this is going to be 90 for angle P. Okay, great. So we have angle N left, and we know that angle N is the question that we're being asked because angle M and P is this, M and P. So what's angle N? That's the question, right? So for angle M, that's going to be plus angle N, which is what we're looking for, and this is all equal to 360 degrees, right? So we're solving for angle N because angle N is equivalent to angle M and P. Great, so we have this, so let's isolate angle N. So maybe we can open up this bracket, so we have Y here. This is plus 90 degrees, this is plus Z over 2, plus 90, plus angle N, and then this is all equal to 360, right? So now that we have that information, we're going to say this 90 and 90 would give us 180, right? So we have Y plus Z over 2, then this is going to be 180. And what else? Plus angle n, which is equal to 360, right? Okay, now hold on. We still have this z, right? Because if you look at our answers, we only wanted x, z, and y. So x plus y, x minus y, or the combination of z and y, right? So we still have to figure this out, right? So if you have angle n, maybe we can solve for angle n first and deal with your z and y. So you have angle n. I'm isolating this. I'm taking 360 minus 180. So I'm just moving the 180 to the opposite side. So I'm getting 180, right? So this and this I'm combining. And then you're going to see that if you move the y to the opposite side, you get negative y. And then on the other hand, this becomes negative z over 2. So let's see what we can do. So apparently, if you have z minus y or z plus y, that does not really answer the question because, or it's not even our answer, to be honest, like C and D, because just by looking at this, there is no way that this is going to be equal to z plus y or z minus y divided by 2 because you still have this 180 over here, right? So C and D are obviously eliminated from our answers, so we're supposed to be looking at A and B alone, right? Because this is definitely not equal to C or D. Even though you try to organize the y and the z over 2, that's no way. There's no way that's going to be equal to C and D, right? Great. So we need to think about z over 2, right? And maybe express that in terms of x or y. So if you go back to the previous ones we've did, let's see. So we need to find an equation where you have z. Okay, so for z, since by looking at the orange part, the green part, we can't really find an equation where it tells us it's just a z equation, right? We need to make our own, like right now, right? So remember, because this is a circle, right? So this arc over here, this is x, right? And then you have y, and then you have z, right? So you're going to say that because you have a circle, right, the complete angle of the circle is going to be 360, right? Why is it 360? Because it's 2 pi, right? That's the circumference, right? 2 pi r is basically your circumference of a circle, but because it's the complete angle of the circle, you're going to say that x plus y plus z is going to be equal to 360. And that's how you come up with your z equation. So you're going to say x plus y plus z should be equal to 360 because this is the complete angle of your circle, and all you have to do is solve for z. So z is equal to 360 degrees minus x minus y. Then this is the one that you plug into your z, right? So you go back to this equation. So you're going to say angle n is equal to 180 minus y, and you're going to have that negative 1/2 here. Then your z is this, 360 degrees minus x minus y, right? And just by looking at this, you can have 1/2 times 360, so that's equal to 180. So 180 degrees minus y, then you have this negative 180 degrees. So I'm going to distribute this negative 1/2 to each of my term. So as a result, this becomes positive 1/2 x, and you get positive 1/2 y, right? So this cancels out. And this cancels out as well, right? So this negative 180, because 180 minus 180 is equal to 0, right? So now you're left with negative y and 1/2 y. So negative 1, and then you have plus 1/2, so that's equal to negative 1/2, right? So in that case, you can say that angle n or angle m and p, they're equal to one another, right? So this is equal to negative 1/2 y, and this is plus 1/2 x. To make this a little bit better and to see where that is from our equation, we're going to say that you both have an x and a y, so you're going to say x minus y over 2, which is B. So that's angle M and P. Okay, so let's see what they have. I told you this is going to be a long one, so bear with me, we're almost there. Okay, so they looked at the triangle, which is LQM. Okay, so this is what they wrote. So they're saying you have this LQ, which is equal to MQ, and that's right, that's the radius of the circle. As I mentioned earlier, you have the two angles equal to one another because it's an isosceles triangle, right? And that's equal to 180 degrees. The reason why it's 180 degrees because it's the sum of the interior angles of a triangle, right? And what they're doing here, exactly the same as what I did, because you're saying that angle QML is equal to angle QLM. Therefore, you can just simplify these two into just one angle because they're the same dimension, and you multiply that twice because you do have twice of that. And this is plus Z, which is this opposite arc, right, of the central angle Q, or the central angle theta, right, because Q is a point. So that's equal to 180. Then they've isolated QML, which is what we did. So we got 90 degrees minus Z over 2, and that's exactly what they have on the left side. Now, if you're looking at LMN as a line, right, you're going to say that it forms a linear pair, the two angles respectively. It's angle QML and angle QMN. That's 180 degrees, and they're solving for angle QMN, and the reason being is because you want to have an equation of angle M. The reason why you need angle M is because you're going to use that information when you're looking at your quadrilateral Q, M, and P, which is what we did afterwards. So now they're looking at angle Q, angle M, P, and N. And that's equal to 360 degrees because what do we know? We know that a trapezoid is a quadrilateral, therefore a trapezoid must also have a sum of interior angles, which is 360 degrees. And what they've wrote is each of the angles, they represented that as a form of the arc, right? Because we can actually look at a circle, use the central angle, and make our intuition based on the central angle. So for angle Q, you're going to say that this is equal to Y, right? Because it's opening this way, and we know that if you have a central angle and you have an arc, right? That means this angle is equal to the arc, right? And you have an angle M, which is coming from angle QMN, which is 90 plus Z over 2, and that's what they have here. And then you have angle P, which is this. So it's a right angle, and it's a right trapezoid, right? And then you have angle N, which is something that we're looking for because that's angle M and P essentially. And that's equal to 360 degrees. And remember, we rearranged this to find angle N, and because we know that it's a complete angle of a circle, right, using all of your arc, and it's a circle, so there is 360 degrees, right? So it's sort of like a reflex angle if you think of it that way. So in that case, rewriting this equation, you isolate Z, and that's equal to 360 minus X minus Y. And all you have to do, right, because you know that just by looking at angle N, this is no way near your options, right, for your A to D answers. Therefore, you're going to maybe look at Z and see if you can express Z in the form of X and Y. And that's what we did. We substituted Z coming from the equation of the complete angle of a circle, which is 360. And then we took 360 minus X minus Y and substituted that into Z. So we're saying now that angle M and P is X minus Y over 2. And I have nothing to say. This is exactly what they did. So it's a perfect solution and answer. Amazing. Okay, so this is done. I don't know if it's just me, but I think hopefully for you guys too, but if you were able to like understand like one math question that was so long and it was so hard, and then there's just this like I don't know like what kind of expression that is, but there's just this relief moment where you actually understand something, and hopefully you feel the same way, because that's what happened just right now. Like we just finished a couple of minutes just looking at just this one figure, and we did it, right? So hopefully that motivates you. But okay, let's move on to this question. So for what value of C will make the expression a perfect square trinomial? Okay, so if you remember, anytime you have a perfect square trinomial, this is basically you need to complete the square. So all you have to do is you take -7, right? You take the b of your standard form of your equation, because this is ax squared minus bx plus c. So all you do is you take -7 divided by 2 and you square that, right? So essentially, we're looking at -7. So -7 divided by 2 and you square. So you square that term. So -7 divided by 2, right? So this is just when you're completing the square. You take your b value, which is -7, you divide that with 2 because that's part of the formula, and then you square that. So in that case, you know that your c needs to be 49/4. So this is your c. And just so you know, if you're interested to know what a perfect square trinomial is, basically, let's say you have this, right? So in that case, if you have x squared minus 7x plus c, you can actually express this in the form of a minus b, and then this is squared, right? So when you are able to turn this into a trinomial, which is x squared, ax squared plus bx, or minus bx in this case, plus c, that's your trinomial. And it's a perfect square because it's twice of that, right? Sorry, not twice, but it's multiplied to itself, right? And it's a minus b times a minus b. So that's why it's a perfect square. Okay, great. So let's see what they wrote. Yeah, so they've actually shown you how to complete the square. So they're taking -7 divided by 2 squared, and because you're adding a new term, that's why you're subtracting that with the same term, 7/2 squared, and then they're saying that c is equal to 49/4, which is exactly what we did. I think I appreciate, so this time I appreciate that they actually showed you how to complete the square, but to answer this question, that's not even necessary, but I just appreciate that it doesn't allow you to kind of guess what's going on, right? As opposed to saying, okay, c is equal to 49/2. So they actually showed you the step on how to complete the square, and then they tell you, okay, so this is just what you do. You divide your b expression with 2, and then you square that. That's why it's c. So nothing to say except it's perfect. So perfect solution and answer. Okay, great. Yeah, so let's move on to this question. What is the square root of 90 simplified in radical form? Okay, so anytime you're taking the square root of something, or even the cube root, right? This is like going back to middle school. Or actually, yeah, middle school. So if you have square root of 90, right? So let's say you don't have a calculator. So I'm not going to use my calculator like right now. So if you wanted to simplify this, what I tell my students is you need to have this synthetic division. So you're going to have 90. And then you're going to just use, I don't want to say prime numbers, but let's keep the numbers as small as we can. So if you have, for example, 90, you know that 90 is divisible by 2. And when I say divisible by 2, you can divide 90 with 2 and you just get an exact number. So you don't get an answer that is a fraction and it's not a decimal. So that's what I mean by divisible. So you can get, you can divide 90 with 2, right? So 90 divided by 2 is basically 45, right? So you know that this is 45. So let's say you wanted to divide 45 with so pick a number that is as small as a smaller, okay, hold on, let me rephrase that. So when you're trying to divide this, right, synthetic division, you need to keep the number, or what do you call this? The dividend, right? Sorry, the divisor. So this is the dividend, right? So this is 90. So this is what you call your dividend. So if you go back to middle school, right, they talk about the dividend. This is your divisor and this is your quotient. Quotient is your answer, right? When you're dividing things. So you're going to pick a divisor and go as small as you can, right? So don't pick like 10, right? Pick, yeah, prime numbers. Just stick to prime numbers. You should be fine. So if you pick prime numbers, right? The reason why I'm doing that is because you need to count how many. For example, if you have a 3, right, you have twice of that. That means you're going to take that and factor that out of your radical, right? Okay, so let me just illustrate that. So let's say you have 45. If you want to divide this with 3, again, we're not using any calculator. That's why I'm doing the long division. So if you have 1, so 15, right? So 15, then you have this divided by 3 again, you get 5, right? So as you can see, because you're taking the square root, right, of 90, that means in a square root, what's the index? So it's 2, right? So when I say index, it's something that we don't really write, but this is basically 2. Because when you have a cube root, the index is 3, right? So in a square root, the index is 2, which we don't write. Does that make sense? So in that case, you need to find a pair of numbers, right? So here you have 3, right? It's a pair, right? So that pair goes out of your radical as one unit. So if you have 3, right, that's 9, right? So if you rewrite this root of 90 or square root of 90, so let's scroll down. So square root of 90, when you rewrite this, this is equal to the square root of 2 times 3 times 3 times 5, right? So what's going to happen in this 3 times 3, it's going to become 9, right? And we know that the square root of 9 is going to be 3. So that's going to come out as 3. So one single unit. And then whatever's going to be left inside is the numbers that don't have a pair or don't come off as a pair. So you're going to have just 2 and 5, which is 10. That's why when you take the square root of this, make sure you have the plus or minus symbol, because taking a square root of a number, you need to have the plus or minus symbol. So just as a recap, apply synthetic division if you don't have a calculator, and what you do is you group the numbers into pairs, right? Because the index is 2. That's why it has to be a pair. So if you're looking at cube root, therefore you're going to group the numbers in terms of 3 numbers, right, as one group. And then you're going to evaluate, okay, so the square root of 9, right, is actually 3, so the 3 comes out, and then comes out of the radical, and then whatever's left, which doesn't come as a pair, which is 2 and 5, that means those are the numbers that will be left inside your radical, and you would have just square root of 10, right? And that's it. So let's see. So we have square root of 90, which is equal to square root of 3 times 3 times 10. So they took out the square root of 9, right, which is equal to plus or minus 3 square root of 10. Exactly. So this is what we did. So yeah, remember synthetic division. That's what I tell even my middle school students. And it works every time, so. Okay, great. I have nothing to say. Everything is right. Okay, so perfect solution and answer. Okay, great. So this is where we're going to leave off, I guess. Okay, I think we still have enough time. Okay, let's just do this question. So we have cosine pi over 4, right? So first of all, what is cosine pi over 4? So remember what I said, pi would be equal to 180, right? So 180 degrees rather. So if you have pi, which is equal to 180 degrees, right? In that case, you're going to take 180 divided by 4 to identify what that angle is. So 180 divided by 4 should give you 45 degrees. So essentially, this question is asking you, what is cosine of 45 degrees, right? And we know right off the bat, cosine 45 degrees is square root of 2 over 2, right? Just to double check. Yeah, it is square root of 2 over 2. So if this is square root of 2 over 2, and how do I know that? Well, if you recall, we have the 45, 45, 90 angle, the special special triangles that we have. Okay, so if this is 45 degrees or pi over 4, this must be 45 degrees as well, right? And then basically we're going to take, so we know that this is 1 or x, and then honestly, let's just keep this as 1. So 1 just for simplicity, and then we have 1, and then we have square root of 2. Great. So now that we have this, right, remember this is a special triangle because it's cosine. We're taking the adjacent side or whichever 45 degrees you're looking at, but let's say we're looking at this. The adjacent side is 1, so that's the SOHCAHTOA, right? Adjacent over hypotenuse, which is square root of 2, and because you don't want a radical in your denominator, that's why you multiply your numerator and your denominator with square root of 2 over 2. Sorry, square root of 2 over square root of 2, which is equivalent to saying it's equal to 1, right? And as a result, we get square root of 2 over 2 because the radical, right, cancels out. Because when you multiply two radicals and they're the same term, you get rid of that square root. So that's why it's equal to 2. Great. So that's why cosine pi over 4 is square root of 2 over 2. And they've just shown you the graph of cos x is, right? Remember, you have your max at +1, you have your minimum at -1, and one period is starting from here until this point. Yeah, so in decimal it's 0.707, but I think at this point, just try to remember your cosine pi over 4 in terms of square root of 2 over 2. I think this will pay off if you do pursue upper year courses for math. So, okay, and this is for science. So I've got nothing to say because they specifically wrote square root of 2 over 2, and this is 0.707. So perfect. Okay, so for this, we're gonna continue on. Okay, so let me just mark where we left off. Okay, so for next class, we will continue on this. Yeah, so I just hope that you found this really helpful, insightful, and also productive. And if you're interested in attending more of my classes, because I not only teach the popular Q&A questions for math, I also do calculus, geometry, algebra 2, you name it. And my daily schedule can be found in oneclass.com/livestream. Okay, let me move this so you guys can see this. So yeah, my daily schedule can be found in this website, oneclass.com/livestream. And also there are other talented educators, super talented educators that are teaching on the or who are teaching on this platform. So if you're interested to see more of my classes and also other classes, make sure to check that website out. And I hope you can invite your friends. I mean, the more the merrier, right? And happy Monday. Thank you so much, guys. And bye for now.